2.5, staying alive. Here we go. Ready, set, go. We are writing equations of lines. We have seen several types of lines in this section, dealing with linear, which is a straight line, which takes on this form right here. Y equals mx plus b, where m is our slope, b is our y-intercept. And then we've also worked with slope-intercept form, point-slope form, which is mentioned down here. So this ready part is super simple, does not take very much time at all. You're given the eventual form that you're trying to aim for. You're given m, you're given b, so just write it out. You have y equals, instead of m, you're putting -7. You're putting x, you're putting b is 4. You're done that. The other two are just like that. The whole point of 2.5 was introducing this point slope form, so another way that lines can be rewritten. For 4, we're given m. We're also given this point here of 0, -7. So just model the equation same way that it is here. So put in y, put in our slope of 9, put in parentheses, put in x, and then subtract x1, which I'm having 0, and then continue to write in that you're adding y1, which is -7. Can this be taken further? Hopefully you're saying yes. 9's outside, x minus 0, you can just rewrite to x. Adding a -7 is the same thing as subtracting 7. So then you can actually just take this further without parentheses, y equals 9x minus 7. But if you wrote this just to keep the point slope form credentials together, then that's okay. All right, I'll actually do another one. Y is going to be equal to our slope of -5. We then hit parentheses, we hit x. We're subtracting x1, which in this case is 4. And then we're adding on y1, which is just 11. So this is it. Done. Super simple. Down here, we're only given the slope, so we have to dig a little deeper. So what do we need? We need our slope. Recall, if you check my screen, we can use our slope formula that was given at the end of this section, y2 minus y1 over x2 minus x1. Super pivotal here. So we've done problems like this before, actually. So I'll call this x1, y1, x2, y2. So y2 minus y1, 10 minus -5. Divide that with x2 minus x1, so -3. Minus 2 up here. 10 minus -5 is really 10 plus 5. Down here, -3 minus 2. You can just keep that as is. 10 plus 5 is 15. -3 minus -3 minus 2 is -5. Can we simplify this further? Hopefully you're saying yes to just -3. All right, so lo and behold, we have our slope, we have a point. I'm actually going to show two interpretations. In this case, I'm going to use the first point to -5. So still starting it off with our slope and x, in this case, -2, and then -5. This is one option you can come up with. What about the other one? Maybe pause the video, try this out on your own. Option 2, when you simplify everything as much as you can, should be x plus 3 plus 10. So you have two options of what you can end up with. Both of these are correct, believe it or not. It's up to you which one you like better. The others are similar, so you should be able to do okay on those. To help you get started with this one, you should be saying that your slope is going to be +3 And yeah, I'll leave that other one to you. All right. So this should help you get started with 8, saying your slope is +3. I help you out there. For the set, we're graphing linear and exponential functions, believe it or not. Linear, I know, has a straight line aspect to it. Exponential is more of an arc. All right. Make a graph of the following based off of the information, add our axes, choose an appropriate scale, label the graph, then write the equation. Ooh, there's a lot going on here. Okay. All right. Beginning value is 5. So that's a big deal. So what I'm going to do first is just write 5 because I'm starting with 5 no matter what. That's a really big deal. And its value is 3 units smaller at each stage. So smaller, 3 units. And this depends on the stage. I'm going to denote the stage as x. So 5 minus 3x. All right. If I wanted to graph this out, I'm going to call this my x-axis. This is my y-axis. Our starting number is 5, which I'm going to put right here. Let's call this x, call this y. 5 minus 3x, it's going over 1, down 3. So this would be 2 when x is 1. I'll even sketch out a table. I think that's helpful. So 0, then to 5. This next point was 1, negative +2. We can keep this momentum going. Just deduct 3, 2 to -1. And it can keep going just like that. That should be sufficient for this one though. Draw this line. Hopefully trying to get it through everything. Hey, now we're cooking. All right. I'm gonna actually let it hang off the graph because hopefully you understand that it could keep going and going. I'll even write this in 3, 4. This was 0, this was -1, this was -2. All right. Beginning value is 16, and the value at each stage is 1/4 of the previous value. So we keep multiplying this by 1/4. So anytime I see a fraction, each stage is 1/4 of the value. I think of that as multiplication, which in this case would be exponential. Okay, so definitely keep x in there. Start your numbers at 16. Let's see, how can we scale this? Well, this is going to be pretty positive for a bit. So let's say that this is our x-axis. This is our y-axis. I'll have this go in increments of 4. So 4, 8, 12, 16. Call this 1, 2, 3. All right. Quick table. I know that our starting point is 16. So let's map that out. If we take a 4th, 1/4 of that is just 4. So when x is 1, the outcome's 2. And then we should just keep multiplying this previous term, or think of it as division by 4. So you can either think of it as multiplying with 1/4 as you move to the next value, or treat it as if it's dividing by 4. Both actually work just fine. 4 divided by 4 would get you 1. So when x is 2, the outcome's 1, which is like about here. And again, we're scaling this by 4s. So we'll keep it going one more time. 1 divided by 4 is just going to be 1/4. So that's even smaller. Doing our best to graph this. Going to draw the arrow just to show that it keeps going in that direction. I hope that helps. Yours could look different, but those are some of the points that I think are really pivotal for these. Okay. Let's go. We saw that the whole point of 2.5 is those two people, Zach and Sion, just comparing back and forth their answers. So what we're doing here is proving the two equations are equivalent by simplifying the equation on the right of the equal sign. The justification examples to help you understand we don't need to justify. Okay, so we're just trying to manipulate this right side as much as possible. So we're trying to manipulate this and this and this as much as we can until it matches the left side. All right, so let's knock out 14 first. What I'm going to sketch out here might be helpful with PEMDAS. And then I'm actually going to modify this. So when we simplify these, multiplication and division can kind of go hand in hand from left to right, and same with addition and subtraction. So I see parentheses here. I'm going to distribute the two. This leaves us 5x minus 7 plus 2 times 3x, which is 6x, 2 times 1, which is positive 2, deducting 10x. So my parentheses are taken care of. There aren't any exponents. There's no more multiplication or division, so we'll just add or subtract. For this, I'm going to color coordinate. I'm going to underline my x terms in blue. And then my constants, the other terms to focus on in pink. Well, they were blue, you know. All right, yeah. All right, so let's actually just focus on this. So looking at 5x plus 6x minus 10x. So maybe on the side, that might be something good to note. 5x plus 6x minus 10x. 5x plus 6x gets you 11x. Subtract 10x, this leaves you with just x, okay? So x is leading the front. And the leftover terms, we'll talk about those. I'll underline them in red. So we have negative 7 and positive 2. Sorry, so these were my x terms. Over here, I'll have my constants. So right here, it has negative 7, adding 2, which gets us negative 5. So just writing in negative 5. This matches up perfectly with what we have here, so I'll just reiterate it. We're done. And they're equal. That's what we want. I hope that this video was helpful. If you have any questions, holler, let me know. Thanks for watching.